Good afternoon, class. Good afternoon, class.
Good afternoon, sir.
Good afternoon,
All
sir.
right. We will start since the other people, I don't know when they will join, so we will start now. Okay.
Good afternoon, sir.
Okay. I said we will start now because we don't know when the other people are joining. So at least you are
Okay,
30,
sir.
36 now. Do you have the electrical people too in the class? Electricals, are you in?
Yes, sir, we are in.
If you're electrical student, let me know.
We are in, sir.
I'm electric. You said.
We are in.
All right. Just since you have informed them, all right. Since you have informed them, then that is okay. So today we are moving actually on a different topic. God willing, next week you will be writing. Yes, we will write. I think quiz. Okay. So prepare yourself for that. Okay. So we are done with the definitions. We are done with the definitions of forms, and also we are done with the how do you call it definitions, and we are done with coefficient of forms. So what we are on now is areas, volume, and what centroid. So we are now on areas, volume, and what centroid. Know all the definitions, know all the coefficient of forms before you also come and know areas, volumes, and what centroids. All right. So I will introduce the course. Now, to enable stability, trim, and powering requirement of a ship to be accurately evaluated, it is necessary to calculate areas, volumes, and centroid of the hull. Now, those that have done maybe internships or whatever we call, when you are in the ship, you realize that the ship is, I will not say, how do you call it? The ship is not sinking, right? It is stable in a certain way, though even if it rolls, it still comes back to its normal position. So what we are saying that now, before you do all this stability trim to keep the ship upright and calculate for its powering equipment, you need to calculate for each area. You have to know the total surface area. You have to know the volumes. You have to also know a centroid. Okay, when I put this cargo here, this is how my vessel will tend to. When I put the cargo here, this is how it will be. These are the things you have to know, especially when you are about to design the hull of the ship before you go on and go in for the construction. So these are the things you have to know. Okay, the very hull. Okay, this you need to know the volume. If someone tells you that, okay, I want my vessel to calculate cement of 50,000, maybe 50,000 tons, you have to know the volume that can actually hold this 50,000 tons of cement. And you also have to know the area. So you have to know the length, the breadth, the width, and all that before you go on for the calculation. So to enable stability and trim and powering, these are the things you have to know. You have to calculate for the area, the volume, the centroid of the hull. These are the basic things you have to calculate before you go on. So for most parts, a ship hull form does not conform to any perfect geometrical figure. Hence, the curves and lines which represent its surface cannot be expressed by a mathematical function. So what we mean is that the ship hull is irregular body of which you cannot calculate. You don't have a perfect geometrical figure that you can say that the shape is rectangle, or the shape is square, or the shape it doesn't have that kind of a perfect shape that you can say, or you can pinpoint that, okay, this is rectangle, this is triangle, this is that. No, it don't have that particular job. So it makes its calculation of area and other stuff a little bit complicated, because if you are the aft, the way the aft is now, when you are going to the middle body, you realize the way it is, and when you are moving from the middle body to the fore, you realize the way it is. So coming out with a mathematical function to express the whole thing is somehow, it will be very somehow difficult. But at the end, we have found a way of calculating for its area, its volumes, and centroid. I hope you understand up to this point. Hello.
Yes, sir.
Yeah. All right. So
Yes,
the
sir.
next point is this make evaluation impossible by the use of integral or calculus. You cannot just sit down and say, okay, we want to calculate for the area of the ship length times breadth. That is all. No, you cannot say just length times breadth. Then you are going. No, you cannot say that. You will not get the specific area. So to overcome the problem, as in it's not having a specific a geometry, for you to overcome that, there are certain things you have to do. Rather than that, you can never be able to calculate for the area, the volumes, and all that. So to overcome the problem, because that has been a problem, to calculate for that. So to overcome it, a special shapes for form geometry is usually created to produce lines and curves, which can then be taken through approximation integration method. A special shapes for form geometry is usually created to produce lines. So now, okay, you see that it's very difficult for you to calculate the whole shape, like coming maybe length times breadth, then you get the area. No, you cannot do that. So then it means that they have developed a special procedures. So sometimes either you divide the whole into smaller parts, then you calculate every part, then you join all before you can get the area. Or you have instrument to measure the whole thing and says that, okay, this is my area. So we also have approximated integration methods. So we have this type of method, the approximation integration method that you can use. You integrate every portion so small. Then when you finish, then you add all. Then you can say that, okay, this is what is my area. Then we also say calculation may also be made through the use of empirical formulas. So we have approximate integration method, and we also have empirical formulas that you can use in calculating the areas, the volume, and the centroid of the hull. I hope you understand that. I hope you understand.
Yes, sir.
Yes, sir. All right. So,
Yes, sir.
okay. So we go to the approximate integration. We said I have two methods. We have the approximation and the empirical method. So we pick the approximation integration method. So typical method of approximation integration are counting of squares. So what I said earlier on was, you see, when you have the hull, now you want to calculate for its area, or the deck, you want to calculate for its area. Then it means that you have to measure it. You have to divide into number of squares. Then you count them. So then when you have squares, then you can say, okay, length times breadth. So if you have a length of maybe 10 meters or 50 meters, it means that you have to divide it small. So you can know the number of squares you get. If you are using 50 meters or 10 meters, you can imagine the number of squares that you have to calculate length and breadth. It's a long process that for you to be able to do that. Then you go to use of mechanical device such as planimeter. Now, when you Google planimeter, you see that it's more or less like using vernier, the inside caliper and the outside caliper. That is how the whole thing is. And you can use this particular instrument to measure. So all of you should go type planimeter. You will see the planimeter there, and also see how to use the planimeter to measure all this area. And we have the integrator. It's more or less those, especially those in the electrical people will understand it. The integrator. It's a form of those doing the PLC systems. You program it, then you put it in, so it will be able to measure all the measurement for you. So we have the integrator. This one, when you Google, you will find and you know how it's being used. Mostly those doing the PLC systems and other stuff, you can program this into your design. Then when you come and attach it to the it will be able to calculate all the holes for you. Then the use of approximate integration method, which includes is in which includes one, trapezoidal rule, mid coordinate rule, and other Simpson's rule, Simpson's first what rule. All these ones are used in calculating for the areas, volumes, and centroids of a ship. These are formulas you can use. We have the mechanical devices that you can use to measure. So if you have them, you can use them to measure. If you don't have them too, you can use mathematical or approximate integration method to also calculate for the areas, the centroid, and volume. And I know the trapezoidal rule. You have used them in the JSS, the secondary school, and all that. You have used them. And I think your Maths 1 or Maths 2, we have also talked about it. Simpson's first rule 2, we'll talk about it, and Simpson's rule 8 rule. So all these things are rules that are being employed for you to use and calculate for your areas, volumes, and centroid. Are we okay? Are we okay?
Yeah.
Yes, sir.
All right.
Yeah.
So if a question is asked, what method can you use to approximate integration, or maybe use to calculate for areas, how do you call it, and all that? You should be able to say it. And a mechanical device that you can also use to calculate for the areas, the volume, and centroid. You should be able to say that. And I said you should go and Google planimeter and integrator. See the device, know what it is used for. Especially those in electrical, you know what integrator is, and when you go, you'll be able to use them. All right. I hope it's clear.
Yes, sir.
All right. So gradually, gradually we are diving into it. All right. So then we go to shape geometry. All right. With the shape geometry, it's more or less like when we are doing tanker drawing. We have the plan, we have the plan, we have the end, and we have the front view and all that. And we have explosion, we have all that. We have to explore the design and know how it, the mechanical all stuff like that. When it comes to ships too, we have ways of interpreting our the hulls and other stuff. So then we go to the body plan. Now, when you say a body plan, what is it? We say by cutting across transversely at 10 equal space sections on stations longitudinal from the aft perpendicular to the forward perpendicular, and the lines produced are projected. A set of 11 curves is obtained, referred to as the body plan. All right. So what we are trying to say is, from the fore and the aft, all of you know where fore is of a ship, and all of you know where aft is. So in this, we are saying that when you divide them transversely, when you divide them into 11, so you can see some black things there. These are the transverse sections that has been has divided the very whole. And we are saying that a set of 11 curves is obtained to refer as the body plan. So we are having some 11 curves here. So when you divide them, this is how you will see you see the body plan. So at every section you divide them. These ones are all to help you to be able to calculate for the volume, for the for the area in the centroid of the ship. Especially this body plan, it will help you to calculate, because as I said earlier on, if you are using the integration method and the approximation integration method, you cannot just calculate the surface like that, because it's irregular body. So it means that you have to divide them. And now when you divide them, you'll be able to calculate for one portion, calculate for the second portion, you're able to calculate for the third portion, so you calculate for the fourth portion. Then you do all the calculation. Then when you add them, you will be able to you will be able to come out with the whole area of the hull or of the ship. So we say by convention, the mid ship section is the reference to ensure clarity. Lines from midship to the aft and are presented to the left, while lines from the forward are presented to the right of the center line in the drawing. So as it's been there, we have to have the midship. So when you have the midship, then you can divide them to the aft. When you have the midship, you can divide to to the fore. So basically, this is what a body plan is. I hope I'm clear. Hello.
Yes,
Respond to me.
Yes,
All
sir.
right. Okay.
Yes, sir.
All right. Understands this as we are going on, so that when you get there, you will not be asking me what is body plan. All right. Okay. So we go to bread plan. The same shape. All right. We are saying the same hole, or let me think, the same hole. We are saying that when the cutting is done vertically from the baseline up and the line produced are projected, the set of curves obtained is referred to as the breadth plan. So we know our breadth, we know our transverse section and all that. So when you say the breadth plan, it's like you are cutting, we are slicing it. When you buy plantain chips, you see the way they have sliced the plantain chips. You see, so you have the plantain and they have the plantain chip slider. Then they will slice it in that area. That is the same thing what you can see here. So that becomes our breadth plan. So when you take the plantain chips, seeing the way they have sliced it, yes, that is the way the shapes are also being done. So you slice it. So from when you have the whole shape, then you stand somewhere, then you cut first face, then you cut the second face, then you cut the third face, then you cut till you get to what? To the baseline of the shape. So that becomes what our breadth plan. Cutting is usually done at 1 meter intervals, and the baseline serves as what reference. So at each and every 1 meter interval, a slice is what being cut. So for instance, if your plantain chips, you pick maybe 1 meter, then you cut. Of which you cannot get 1 meter on the plantain chips, but maybe 0.0 something of a plant, then you cut. So that becomes what your body or your breadth plan. Since the whole form is symmetrical, port and starboard, it is usual to produce the drawing in half to give a half breadth plan. So when you cut it, you'll be able to have half breadth. You have half breadth and you have the full breadth. All right. So we go to share plan. So the same shape, you have been able to cut transversely. You have been able to cut horizontally. Now you can also cut in this form. So share plan, when cutting is done transversely from port to starboard, the third set of curves to obtain is referred to as the share profile. So as you can see, transversely you have been able to cut. So this one horizontally you are cutting the shapes into sections. All these ones to help you to calculate for the area, the volume, and the centroid of the shape. Are we clear? Can I move on? Please respond. Can I move on?
Yes,
All
sir.
right.
Yes, sir.
All right. So
Yes,
we
sir.
have that.
Yes,
So we
sir.
have the body plan, which is like this. We have the breadth plan, which is like this, and we have the share plan. Now, when you combine all, this is so as a naval architecture, wherever you see these things, you should be able to, even if the names are not on it, you should be able to know that, okay, this is body plan. This is how body plans are being presented. This is how share plan is being presented, and this is how half breadth plan is being presented in any drawing that you see, or any drawing, even if they have not written anything on it. So we say finally, when the three set of drawing are put together, a lines plan is produced. So these ones are lines plan, and as a naval architecture, these are the things you have to interpret, and these are the things you have to draw. In it, the body plan is imposed on share profile at the middle, while the breadth or half breadth plan is presented below. So these are the what we call the lines plan, and these ones are very, very important. Those that will be advancing. These are some of the things you yourself have to know. So when you see them, you will see the body plan, you see the share plan, profile, and you see half breadth profile. When you see them, just know that these are lines plan. All right. Then we go to table offsets. Now, I hope some of you have done internships before, right? Or you have been into shapes before.
Yes, sir.
All right.
No.
No, sir.
No, sir. No, sir.
You have not.
Yes, sir.
Do you have the chance to do internship?
Not so, sir.
Do you guys have the chance? You said
No, sir. We
do
never
you
had a
guys
chance
have the
because of this
you
pandemic.
never had a chance to okay because of
The
the COVID. Okay. All right. You see, we have what we call offset. We have what we call table of offset. All right. The diagram that you are seeing, what line plan is that?
I'll go collect the guy.
Those making noise in the background, please off your. If you don't have anything doing, just mute your speaker.
Understand? That guy not too serious.
Those talking, mute your speaker or your hot.
Guys come on for this school.
Let me see. Michael, mute your speaker. All right. So we go on. What plan is this? What line plan is this? Okay, this is the body plan. So we are talking of offset. So we say by setting off distances from the center line in the body plan, a set of coordinates are obtained to produce a table of offset. You know, mostly there are different ways you can design the vessel. There is a software that you guys were supposed to do, but then because of the COVID, you will not be able to do that. But then I will maybe when maybe the COVID goes and you guys will
be judged now again. That nonsense guy will claim nonsense.
Who is that? Michael. All right. How do you call it? We suppose that one is very easier for you to understand. But here, just imagine yourself in the center of the ship or of the hull. You realize that from the mid section to where the platings are, from the mid section to where the I'm getting feedback. Who is this, Michael? We from the center to where the plating is. Using the diagram that you see there, you see that we have the center line, and then from the center line up to where the platings are, we have some numbers. Aft perpendicular, we have half. We have 1, 2, 3, 4, 5, and goes up to what forward what perpendicular. And we said that these are the lines. These are the body plans. And down there we have 0, that is WL. When you see the WL, that is what water line. So we have water line 0, that is the baseline. We have 2 meter water line, 4 meter water line. So this becomes the depth of the hull. So when you look up there, we have shape particulars, name MV nautical, and we have displacement 12,620 ton. We are saying that the LO, that is the length overall, is 162.00 meters. We have length between perpendicular, breadth and depth, and the depth is 7 meter. So here we have the, how do you call it, the water lines at the breadth at the side of the body plan, and we also have we have the other side. We have the water plan, the water level. So for instance, we have cut the shapes into various sections. So from the 0 to 2 meters, 4 meters, 6 meters, 8 meters, and it goes on that way. So what you can do is, you see, we also have boxes. We have in the distance, we have a lot of boxes. So when you pick one, for instance, when you pick one, where my cursor is, you see there is one there. So from 0, you will know that if you want to read it from where the water line is, you realize that you're having 10 meters. Is between the 10 and 12 meters. So the 10 and the 12 meters, when you count, realize that from the 10 to 12 meters, we have 1, 2, 3, 4. 4 how do you call it? 4 lines. So you can see that where the 1 is, it falls on on the so you can have 10.6 or 10.7 from based on the interval from 10 to 12, there's some interval there. So you have to calculate. Then you can trace where the one is. You realize that you get a certain number. You have to record that number. So you'll be able to record all these numbers where they are actually falling. Then you put them there. That becomes what? Offset. So let's use this as a typical example. So table of offset. We have the table of offset here. We have the various water lines. We have the aft, we have the mid section, and we have the forward. So when you pick this, take this as what? As the ship, the earlier presentation that we did. Take this as a ship, this box as a ship. So if you want to read the offset, when you are at the aft perpendicular, here we have the water line 0, 1, and 2. So you have to put your water lines there, 0, 1, and 2. Now, you want to go to the aft. So you pick the aft point. So when you pick the aft point, realize that the distance from the aft to the shaft, to the hull is y0. So you put the y0, that's the distance. Then you come to the midship. So when you come to the midship, it also has a certain distance from the midship to what? To where the plating is, or to that end. That becomes what? Y1. Then you come to the aft perpendicular. You realize that with that one too, we have from that particular aft perpendicular to where the plating is. That becomes Y2. On that is what is the first water line. That is the 2. Then you go to the 1 water line. With that one too, you can calculate from the aft to the shell plating. You can calculate for the other place to the shell plating. You can calculate for the other place to the other shell plating. So you have Y0, Y1, and Y2. Then you go to the last water line. That place you can calculate for Y0, Y1, and Y2. So these are table of offsets. These are actually how you can read your table of offset. So when you go into the ship, you yourself can divide a lot of water lines. That is horizontally, you can cut the ship into various sections. Then when you cut from the midship to where the plating is, you can measure, then you put it there. From the midship to the other where the plating is, you can measure and you put it there. So this is actually how you can read table of offset. And this particular table of offset is very, very important. So with this table of offset, this is the explanation to this particular one. So you have this, so you read this, then you use it to fill here. So you have the you have the water line. When you check from the table, you see that we have water lines here. And the water line, we have 12.20, 10 meters, 9 meters, 8 meters, 7 meters, 6 meters, and all that. So these are the water lines. So when you go here, these are the water lines. The 0, 2, 4, up to 14. That are the water lines. Then you go to the aft end. AP, half, 1, 2, 3, 4, and up to the forward. So here to when you come here, realize that we have the aft, we have the half, we have the 1, 2, 3, 4, up to Up to the aft perpendicular, as you can see here. So now when you pick the aft, then you go to where we have 11.20, or let's go to 10 meters, and it's forced on 11.70. So when you come here, you can pick your 11.70. So you realize that your 11.70 is here. So where is the, how do you call it, the line falling? So when you get to 1, you realize at 4.50. So you'll be able to read it from here. 4.50 will be read from from the table. So basically, this is how you can read your offset. You have to sit down, practice this, then know how to
Sir, please come again.
All right. You see this particular one, this particular table of offset. We have aft perpendicular, and we have forward. We have forward perpendicular. Is that not it? All right. So what I'm saying, to read offset, when you say offset, basically the English word for offset is maybe you have a center. You have a circle. You have a circle and you have a center in it. So the radius from one end to where the circle is, that becomes what? That becomes your one way the other, your for radius. Is that not it? So when you pick a rectangle or a square, you have maybe a center in it. From that center to where the other line will become what? Offset. It means that you have offset a certain distance from it. So from your end where you are standing, now you can tell someone to move a certain distance from you. If the person moves a certain distance, it means that the person has offset from you. That the person has moved from you a certain what? Distance. That's all we are trying to what? We are trying to do. So with this particular box, we have a center line. Now we are moving a certain distance from that particular line to a certain distance. So that distance becomes what? The offset. So we have table of offset. So with the diagram, you have different types of what? Offset. So in the shape hole, you have the shape hole. You will be able to what? To deduce a lot of what? Offset within it. As time goes on, you just have to analyze it, or maybe when you get to any shape or something, or maybe when you Google a table of offset or YouTube, you will be able to get a lot of, how do you call it, images, diagram showing how the offset is being what? Calculated as or is being what? Is being done. So basically that is the meaning of what? Offset. Do you understand it now? Hello? Do you understand it now?
Yes, sir.
Yes, sir.
All right. So just sit down, compare this one and the other one. You'll be able to read that. Okay. Review of the integral what? Calculus. So how do you call it? We said initially that we have different types of calculating for the areas, the volume, and all that. And we said that you can use the devices, and you can use the imperial method, and you can also use what? The integral method. So this is how do you call it? Integral calculus. So you have done how do you call it? Mass. I think mass 2. Yes, mass 2. So this what we have put in there. You should be able to understand it. I will not be going through all the how do you call it, the mathematics in here. So since we have done mass 2, we are still doing mass 2 or mastery. Mastery, right? You are doing mastery.
Yes, sir.
Yes. So you did.
Yes, sir.
You did
Master.
this last semester, or you are doing it this semester?
This
You are doing
semester.
all right. So
We're still doing it.
yes. So here we are calculating for the A is equal to integral of 0L y differential of what? Y. So here we are calculating for the area. You'll be able to calculate for the momentum using this diagram here. So it's more or less when you're having this curve, you should be able to calculate for your area of the surface. You should be able to calculate for the momentum. Should be calculate all of this kind of calculation. You should be able to calculate for it. So please try and go over this and understand them. This is a proof, but I will not prove it here. So just understand them. All right. So initially, we said that we can use of approximation integration method, which include trapezoidal rule and Simpson's rule and all that, mid coordinate rule and all that. So we will now use the Simpson's first rule. We will now go and use Simpson's first rule to calculate for areas and all of that. So we have already said that the shape is very difficult to calculate for its area, honestly. That if it's because it's irregular hot bodies. So it means that people have sat down to come out with a lot of ways to calculate for its area. So we are using the Simpson's first rule. It's a rule. Honestly, it's a rule. Someone have sat to come out with all these rules. You need not to, come to generate your own thing. It's a rule that each and everyone has to follow. So we are saying to obtain the area under a curve, erect 3 coordinates. So Simpson's rule is saying that to obtain the area under a curve, erect 3 coordinates. That is y0, y1, and y2. So from the diagram there, realize that we have y naught, y1, and what y2. This one, there is no argument. This is what Simpson is saying. At equal or common spacing or intervals. So at equal or common what interval. So that is represented by h. So we have y0, y1, y2 being, how do you call it, dividing what the surface. Then at equal what interval. So at each interval we have a certain what, we have a certain interval, and it should be of equal between the limit under consideration as shown below. So this is it. Multiply the coordinates by the equation 1. Please, that thing there is not 3, it's 4. We have 1, I will change that, okay? We have 1, 4, and what? And 1. So you say multiply the coordinates by the equation, the quotients 1, 3, 4, and what? And 1. So that is what Simpson is saying. So when you have y naught, you should multiply it by 1. If you have y1, you should multiply it by 4. If you have y2, it's multiplied by 1. This we have to prove a certain formula. But then with this one, so please go and learn how to prove Simpson's first what rule. Go and learn how to prove what Simpson's what first what rule. Multiply the coordinate by the quotient 1, 4, and 1. Please, it's not 3, it's 4. All right, I will make that changes. Referred to as Simpson's what multipliers. So this particular one is referred to as Simpson's what multipliers. So the Simpson's multipliers are 1, 4, and what? And 1. So, and that particular thing is referred to as what? Simpson's what multipliers. So if I ask you what are Simpson's multipliers, you should be able to code them 1, 4, and what 1, respectively. And thereafter, sum up the 3 products. Finally, multiplying the Simpson's sum so obtained by the common interval and divide the result by 3 to obtain the area. So if you are asked to calculate for this area, you realize that this particular object here is irregular, but it's very difficult to calculate for its area. If it's a square, you will be able to calculate. You will just say length times breadth. You will be able to calculate. If it's how do you call it, rectangle, you will be able to calculate for it. But with this one, you see the shape, it will be very difficult for you to calculate for it. So here we are trying to tell you that these are the formulas you can use to calculate for the area. So we have A, which is equal to the intervals that you have. So from the 0 naught to the L, you have the L to that y1 is h. So you divide it by 3. Already you have divided 10 into 3 parts. Then you multiply the y naught by the Simpson's multiplier. You multiply the 4 by the y1 by the Simpson's multiplier. Then you multiply the y2 by the Simpson's multiplier. So in summary, we are getting the area of this particular object to be y over 3 sum multiplied by what? The Simpson's multiplier by what? The intervals that you have divided. Please, do you understand this?
Yes, sir.
Yes, sir.
Yes, sir.
Absolutely, sir.
You understand it?
Sir.
Yes, sir.
So what are the Simpson's multipliers?
Yes, sir.
What are the Simpson's
1,
multipliers?
4, and 1.
All right.
1, 4.
Okay. All right. Then please go and learn how to prove the Simpson's multipliers. All right. Okay. So we go to shape hydrostatic what? Data. So now you have been able to know some of the formulas and go and learn the trapezoidal rule in calculating for the area and the Simpson's. This is Simpson's what? First what rule. Learn all of them. So we go to shape hydrostatic data. This data is very, very important, especially when we are never like then we are starting the ship design. These are the first things you have to calculate for. These are the very first things you have to calculate for. And for every ship, the following properties are required to be calculated for the hull to produce the hydrostatic data. So these are the first thing you have to calculate for. You should be able to calculate for the area, water plane area at every draft. So you already know a draft already. So at every draft, you should be able to calculate for what the water, what plane, what area. So when you, for instance, if your draft, if you're having 7 meter what depth, at each and every draft of the water plane, you should be able to calculate for it its area. Every draft you should be able to calculate for its what area. Cross-sectional area at every section. So using that, the section at the fore, at the very fore will be different from at the midship. That is the cross-sectional area at every what section. It will be very different, and that is the symbol CSA, cross-sectional. So you should be able to calculate for all this, so that when you are bringing your machines, when you are putting on how do you call it, tanks and all that, you will be able to know exactly the dimensions and where you can put them. Then we go to the longitudinal center of flotation. Yes, you should be able to know how do you call it, the flotation, where maybe the ship will be able to float at a certain point, and then that you before realize you have capsized. Transverse center of flotation, you should be able to know that. Second movement of area about what midship, should be able to know that, to know the forces and all that. Second movement of area about the neutral axis, you should be able to know that. Second movement of area about the center line, you should be able to know. The volume of displacement, how many water has the vessel displaced. Longitudinal center of buoyancy, you should be able to know. Transverse center of buoyancy, we'll learn the meaning of buoyancy and all that. Vertical center of what buoyancy, all this one you should be able to know them as a naval architecture. So we'll be taking them and we'll be working them one after the other. How to calculate the water plane area, how to calculate for the cross-sectional area, how to calculate for the transverse center of flotation, how to calculate for the volume of displacement, and all that we will be able to calculate for it. And the diagram here also depict that. So the down one, the first one, so that at every point where there's black, where is that black, at every point you have to calculate for the area. So using at one water point, at a certain water plane area, you can be able to calculate for that. At a certain water plane area, they have been able to calculate for that. And the other one is section. You see that the section at the fore is different from the section at the midship. Realize that the section at the fore is different from the section at the midship and all that. You yourself, you can see the sizes. You realize that they are all different. So basically, these are the hydrostatic data. So if someone asks you what are some of the hydrostatic data, or they bring in something, the following are part of hydrostatic data, except, so you have to know all the things that are in hydrostatic data. All right, any questions so far?
No, sir.
Hey, any questions so far? I need someone also to talk to see whether there are no questions. Any question?
No, sir. No, sir.
All right, so we can go on, right? All right, okay. All right, so that is shape hydrostatic data. All right, so let's start with water plane area.
So I have a question.
All right.
Yeah, so all of those cheap hydrostatic data are actually used to calculate for the stability of the ship, isn't it?
Yes.
In general.
Yes. You have to know all this so that you'll be able to know how your vessel is stable. Other than that, there are certain, we have IMO solars and all standards, so they will tell you this and that. So when it's above this particular number, it means that your vessel will capsize. If it's above this particular number, this is so. Basically, all this hydrostatic data is for you to understand how the ship will behave in its environment. I hope you understand that. Okay, are you clear with that?
Yes, sir.
All right. Okay. So we start by calculating water plane area. So the first diagram there, you realize that let's take the first diagram as as your ship with maybe 10 meter long. Let's take that as a ship with a 10 meter long. And this is actually the hull of the ship. Now you want to calculate for the water plane area at each and every section. You see, when you go to the other one, you see that the first drawing here, we have at every section we want to calculate for of 8 water planes. So we have 1, 2, 3, and all these places we want to calculate for 8 water planes. So when you come here, this is the fore end, and this is the aftward end. Now, using Simpson's rule, we says that how do you call it? We have to divide the ship into various sections. Now, these various sections will help you to be able to calculate for the total area of the ship. So here we are taking half breadth, and when we say half breadth, for instance, you have divided the ship into 2, and we have thrown one away, and we are below with 1. So with this particular diagram, we have the half breadth, that is one end of the ship. So it's not full. And now we have the aft and the midship. So we have our sections. So we have our first section, second section, third section, fourth section. Then we come to midship. We have the sixth section. So we have divided the ship into various points. And now from the mid section to the plating. So the first one, you see that is very short. The Y1 is very high. The Y2, the Y3, the Y4, and all that. So here we can see that we have under the 1, we have 1 to the plating, which is the Y that is the function. So using half breadth, also called half coordinate, then by equation. So we have 2h, that is the intervals of every section. So 2h over 3. So here we are saying that Simpson's rule says that y0 should multiply 1, y1 should multiply 4, and y2 should multiply 1. And this is the formula that has already been reduced. So when you come here, the 0, 0, 1, and 2, you should be able to have a certain the formula says that it should be 1, 4, and 1. So you have gotten that. And the thing also is very long. We have up to 10 y10. So it means that it will not be able to capture all the formulas. So what we can do is, now when you get the 3, it still has to continue. You still have to continue, but you cannot continue by saying that, okay, I have gotten 1, so I'm adding another 3, 4, 5, 6 and counting that way. No. It means that you have finished with 0, 0, 1, y0, and y2. So you go with y3. But then before you go to y3 or the third station, you still have 2 here. So the 2 means the 2 here, the 2 section is more or less like you have joined 2 sections together. So you have to split them. So when you get to the section 2, it means more or less you have 2 sections. So you have to split them. So if you have to split them, then it means that you have to start with another formula, the same formula, but here is multiplying y2. So we have 1 times the y2, 4 times the y3, and 1 times y4. So you go on again by saying that the formula also keeps on telling you, so 1 times the y4 plus 1 times the y5 plus 1 times the y6. All this thing that we are doing is to calculate for the total area, water plane area of the ship. So when you finish all this, mathematically, you can bring all the 2h over 3 outside. Then you add all the, the numbers within the bracket. So when you have this, so you can put the 2h over 3 outside. You have the y0 plus y1 plus the 2 here. We will come to that. Y is 2, 4, 2, 4, 2, 4, 2, 4, 1. We will come to that. So in summary, we're having the water plane area is 2h over 3 into bracket. The summation of all the Simpson's rule times times the sections that has been there. So by table, you have the water plane area is equal to 2h over 3, which is the 2 is what the interval, which is the h from AP to 1. What is its interval? From 1 to 2, what is its interval? So you have it. Then we have the area product. When you sum all these things together, you will have what area what product. So that becomes what a water plane what area. By using the Simpson's rule, a water plane area is equal to 2 over h 2h over 3 into brackets what the area what product. So when you pick the table here, you have the sections, and you already know sections. So the sections, we have the aft perpendicular and to the forward what perpendicular, and the numbers has already been given to you. So you multiply by what its coordinate, and the y0, y1, y2, y3 that you are seeing, they are all what coordinate. That is, the coordinates are from the mesh section to the plating. So that becomes what your coordinate. So we have the 0 north coordinate, 1 y coordinate, and all that. So you put it there. Then we come to the sets. The Simpson's rule, first rule, says that okay, we have 1, 4, and 1. But then the 1, that is when you come to 2, realize that I said you should take it like, how do you call it? The sections are into 2, and you have split it. So now when you split it, you get 1 there. You get 1 to the other side. So then you start from 2, 3, and 4. From the 4, then you split that 1 too. You can get 1, a midship, and 6. So from the 6, you can also split that one. Then you go to 7, 8, and 9. Then you come to what? To the aft perpendicular. So basically, we have the 1, 4, 1. Then the 1 also is here. So when you add the 1 to 1, you will be able to get to 2. So we have 1, 4, 2, 4, 2. Then it goes up to 1. This Simpson's rule will only fit when you have what? So now I have 1, 2, 3, 4, 5, 6, 7. The sections 1, 2, 3, 4, 5, 6, 7, 8, 9, what 10. This becomes what an even what number in what in the how do you call it, in the sectioning of the whole. Now, if you are going to have odd numbers, it means that you cannot use the Simpson's rule because you are having 1 to 1. So if you end by 4, it means that you cannot use this rule. It means that you have to go and use what different what rule. All right. So if you multiply this particular Simpson's rule by the coordinate, you will get what area product. So we have the B times the C, which is what the Simpson's rule. You get the area product. So 1 times y not y times 4 and all that. When you sum it up, then at the end you will be able to sum it up. So let's go and pick what a question and solve so that you know how it all works. So let's work an example so that you understand it. So the semi-coordinate of a ship's water plane, which is 60 meters long, commencing from the forward as follows. So we are saying that the semi-coordinate, and realize that these are the coordinates from the mesh section to the shell plate. From the 1 to that becomes what your semi-coordinate. So we are saying the semi-coordinate of a ship water plane, which is 90 meters long, commencing from the forward as follows. So we have these are what? These are the coordinates 0.0, 3.8, 4.3, 4.6, 4.7, 4.7, 4.5, and it goes on and it goes on like that. So we say find the area of what? Of the water plane. All right, so here we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You see, we have 1 point respectively. So here we have our section, the aft and what? The forward what? Perpendicular. So 1, 2, 3, we have that one there. Then at the aft, we're starting from the aft perpendicular because it starts from the last word to the forward. So we have the forward and we have the aft. So at the aft, we are getting 1.0. Then we go to the first coordinate, which is 2.8. Then we go to the second one, which is 4.0. Then we go to the third one, which is 4.3. All what we are doing is we are measuring from when you pick the one. We are saying that from the dot to the plating there to this particular line is what we call the it's the number here now. So when you pick the 1, it's 1.0 meters. So it means that from the one here, from this particular midship to the plating here is 1.0. So when you go to 2, from the midship here to this particular end becomes what? 2.8. Then 4.3 will be from the 3 to the other side to the plating becomes what? 4.0. So what that is the half coordinate. So you put all the half coordinates there. Then you go to the forward perpendicular. It means that is at the end part at the dot there. That becomes what? The forward perpendicular. So you are having 0.00. Now we want to find for it area. So we will multiply by what? Simpson's multiplier. So we have 1, 4, 1. So at when you get to the 1, then it means that at that end that's split. So we have 1, 1. So you add that one. So we're having 1, 4, 2, 4, 2. So this one is when you are combining it. So when you combine them, that's what you have. So you multiply the 1 by the half coordinate. So when you multiply the Simpson's rule by the coordinate, you will be able to get what? The area product. So 1 times 1 will give you 1.00. 4 times 2.80 to give you 11.20. 2 times 40 to give you 80. 4 times 4.30, it will give you 17. So you multiply all of them. When you finish, then you sum them up. So when you sum all this area, you are going to get 116.80. So when you get them, then you can say that now the h is interval. So the h becomes what? The interval. At what point did you divide the whole length? So here we divide the whole length into what? Into 10 equal parts. 1, 2, 3. So from 0.0 to 3.8 is one interval. From 3.8 to 4.0 is one interval. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 equal interval. So if you want to find h is the length over the intervals at which you divided you divided the whole length. So you will get h to 6 meters. That is at every point from this particular diagram, AP to 1. The AP to 1, it means that becomes 6 meters. From 1 to 2, that becomes 6 meters. From 2 to 3, it becomes another 6 meters. From 3 to 4, it becomes another 6 meters. So that is it. You have been able to calculate for your meters. Then when you are about to calculate for your water plane area, you already have the water plane area, which is 2 times h over 3 times the summation of of the area product, this particular formula. So now you can, and you have also summed this particular area, 118.8. So when you multiply that, you are going to get 467.2 meters. So this becomes your water plane area of the ship, or at that particular point, this becomes your water plane area. Please, do you have any question? Hey,
No, sir.
are you sure you understand?
No, sir.
Yeah,
All right.
Yes, sir, you understand.
I'll ask.
Please wait. The sets, are they giving the questions?
Which one?
The sets.
The 0.0, 3.8, 4.3, and all that.
No. The one with the 1, 4, 1, 1, 4, 1. That one, is he giving the question?
No, sometimes you have to come out with the how do you call it, with the sections, because this was the question that I was giving. This one is a solution. You understand? And this is the semi-coordinate of a ship's water plane, which is 60 meters long, commencing from the forward as follows. Find the area of the water plane. So now you have to deduce. Now, okay, it has been okay. So you count the intervals: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you have the forward and you have the aft. then you deduce your section. You have your aft and you have what? You have your forward. So then you can deduce that. Then you bring your semi or coordinate.
Sir,
There's
Oh, okay,
I have
sir.
a question.
Yeah.
Sir,
Which one?
said
when calculating the water plane area,
Yeah.
are you supposed to start from the aft perpendicular first, or you can start from the forward perpendicular? So,
All
from the
right.
form-
From the formula.
Yes,
All
sir.
right. Mostly you have to start from aft perpendicular because that is where you are taking your reference from.
Okay, sir. Okay, thank you, sir.
Sir, please, the H, can you go over how you got the H, please?
All right.
Yes.
The H I said is the intervals. So in the question they said that 6 meter long. You understand? So then how then did you get your sections? How did you divide the ship into 9? You see, you have 6 meter long something. So it's up to you to divide the 6 meter long into equal section. So if you want to divide that, then based on the number of coordinates that you have, you see, based on the number of coordinates, you divide that number by the 60. Then you can be able to get the equal interval. So the intervals are basically, the H is basically the intervals from your aft perpendicular to your forward perpendicular. Do you get it now?
Yes, I got it now. Yes.
Or it's still something.
I get it now.
Sir,
Yes.
I was asking of the set, not the section, the sets. How do you get a set?
Yes, and the set, the 141 something.
Yes, sir.
I
Yes,
said
sir.
that one, they are the Simpson's multiplier. You see at the end, the top there is Simpson's multiplier.
Yes,
It's
sir.
not. This one is for explanation. Please don't go and do this in examination or maybe a quiz or something. Like you write set and we are trying to explain it. What we are saying is, you see at this particular point where the Y naught is, you see
Yes,
where the
sir.
Y naught is. We want to calculate
Yes,
the area there. Okay.
Yes, sir.
We want to calculate the area there, and therefore, for you to calculate the area, if it were to be a rectangle, if it were to be square, you will just length times length. Is that not it?
Yes, sir.
Then we will be able to get our total area there. Is that not it? But you see that this
Yes.
one is not square. Neither is it how do you call it a rectangle. You understand? It's having
Yes, sir.
it's having some irregular shape at that particular point. Yes. So what we are doing is, okay, then multiply the H. You see, multiply the
Yes,
H or the coordinate that is from the point 1 to where the curve is. You see, that is the Y naught. Multiply that by a certain formula someone has developed. That is the Simpson's multipliers. And he is saying that the Simpson's multipliers, whenever you divide anything, divide it into 3 equal parts. Then
Yes,
why not make it Y1? Then the middle one, which is the Y1, make it 4. And the last one, the Y3, make it 1. You understand? Yes. So
Yes, sir.
you have the 1, 4, 1 there. That becomes the Simpson's multiplier. Now, you see that when you go to this particular diagram, we have the 0, which is 1. We have the
Yes.
Y naught, which is 4. Now we have the
Yes.
Y2, which is another 1.
1.
Yes.
Yes, sir.
Now, the thing, you cannot go back and start by Y naught again. You understand?
Yes, sir.
Yes. You have to continue from there, from the where you stopped. So it's more or
The
less
Y.
like, yes, from the Y1, from the Y2. Now, when you are
Yes.
starting, the formula also is saying that when you start from Y1. Is that not it? Like we have to start from 1 again. So then at the Y2, you are starting from another 1 again. Yes, another set. So then if it's another set, it means that it has to start from 1 again from there.
1 again.
Yes.
Yes.
4 and 1. Then you have to also start from where it ended. 1, 4, 1. You see? So when you finish that, it becomes mathematics. So here the 1 plus that one will become what? 2. Then we have the 4. So we have 1, 4, 2, 4, and you get to that particular hot area. So that is how come. So he's saying that if you multiply the Simpson's multiplier times the coordinate, if you multiply this one times this, you should be able to get the area of this particular place. Then you have to get the area of this, get the area of this, get the area of this. So all these places you have to get the area. So when you add all the areas together, you see, when you add the 4 areas, you'll be able to get what the total area. And the 2 here is, since it's half breadth, now you want to have the total area of the place, of the surface of the ship. So if you want to have the total, just multiply it by what? By 2. Okay. So when you multiply all by 2 by the area product, you should be able to get what? Should be able to get what? The water plane area of the ship. So the water plane area of the ship will be able to tell you exactly the area that you are having. Okay.
Yes, sir.
All right. So this is basically that. So there are a lot of questions that you can you can solve. So we are saying to improve upon accuracy, intermediate coordinate may be introduced. This modify the equation by. All right. You see, how do you call it? This is just when you have how do you call it? You have one area, you have the second area, you have the third area, you have the fourth area, and you have in that. Please, any question again?
Yes, I have a question. So with the addition of that two, it actually means you're calculating the whole total area.
He said you have to do it.
I said with the addition of these 2, that's 2 multiplied by h over 3. That actually means you're calculating the whole area of the water.
Yes, the whole area.
So you don't multiply, you're actually calculating the half breadth.
The half breadth. All this while we're calculating for half breadth. This particular one.
What I'm saying is that without the 2.
Without what?
Yeah, but you said initially you you made a statement that the addition of the multiplication of these 2 actually means we're calculating the whole area of the water plane. But without the multiplication of the 2, times we're calculating with only the half breadth of the water plane, right?
Yes. What you mean, we are calculating for the half breadth. Because already we are at the top there, we're having half coordinate. So it means that we are not having full coordinate. You see, we are having half coordinate. So when you multiply by 2, it means that you are calculating for all the areas.
Water plane area.
Yes. Any question again?
Sir, please, will they always give us the ordinates?
The ordinates. Yes. Well, it depends on the question. The question, some will give you ordinate. No, we have different types of calculating for this particular area and all that. So some they will give you ordinate, some to have to find your ways, but mostly we'll be giving ordinates to work with it. Yes.
Please, finding the water plane area. Are you supposed to solve it straight, or you need the diagram there, the table diagram to solve it?
Oh no, the table is just for you to explain. Is it the table or the diagram?
I mean, when the question is given to you, are you supposed to create your table depending on the question, or you have to solve it directly?
Yes. Honestly, you have to create a table. But without a table, how can you? No, you cannot do that. So you have to first create your table, know where your sections is, your half breadth is, your Simpson's multiplier, your area product. That is when you are finding for water plane area. Then you'll be able to solve it. If you don't solve the table, you will lose a lot of money, because this table actually tells exactly. Because without a table, how then do you solve for your water plane area?
I mean, from the formula you gave us, I think putting it there and punching also can be better.
Then you punch, then you put it there. No, show working.
Okay, thank you, sir.
And you have to prove yourself. You have to show why we should give you that. Yes.
Okay, sir.
Yeah. So, gentlemen, any question again? Any question again? Any question again?
Say the H.
You said
The H.
the H.
The H. Why did they divide it by N?
All right. That is the interval. And I said that you've seen, let's go to this particular end. You've seen this is the vessel. We have divided into 10. So here they give you a coordinate.
Okay, so I've seen it.
They've given coordinate. Have you seen it now? Have you seen it? Hello.
Yes, I've seen it.
You have seen it. Okay.
Yeah, I've seen it, sir.
All right. So
Yeah. I've seen
any
it.
question? Any question?
No, sir.
No, sir. All right, so we can go on. So please carry go on.
Yes, sir.
All right.
Sir.
Yes.
All right. So we move on. Water plane area. So still calculation of how do you call it? This one. So water plane area coordinate. To improve upon accuracy, intermediate coordinate may be introduced. The modifiers, the equation modifies too. So here, what we are saying is, the more you create sections, the more accurate the whole thing becomes. So for instance, if this particular diagram is divided by only 3, you realize that you might not be able to get it accurate, in a sense that there are a lot of calculations that will not be captured. But the more you divide it, the more you create sections, the more accurate your vessel becomes. It's a principle here. So the more you divide it, the more accurate your calculation becomes. If you divide very small, you will get small. You will get small. If you divide it very big, you will surely get a big derivation. So water plane area, I say, to improve upon accuracy, intermediate coordinates may be introduced. This modifies the equation modify 2. So here we are introducing, how do you call it, intermediate coordinates. So from the diagram, you realize that from half perpendicular to 1, we have divided it again. We have divided it again just to make it accurate, and make the whole accurate. And you go to the half 2, we have also divided it, all in terms of making it accurate. And so this becomes the formula. So here you are having the h over half. You are dividing the half. So the h now you have to divide you have to divide into into 2, because already you are dividing that particular h into 2. So when you do that, then you can move on. Still the multiplier still goes on, the 1, 4 and 1. So the multiplier still goes on. But since we have divided this one to be there. So let's see this. So here we have the half perpendicular, and we have half. Before we go to 1, we have already divided, so we have half there. Then we go to 1, 2, 3 and 4. So when you come to the half coordinate, you have the y half, because we have already divided this one into half. We have the 1, the 2, the 3, and it goes on like that. And we also have the set. So the set, the top becomes then half, because if it's 1 and you are dividing the 1 into that, you become half. So when you divide this one, it becomes 2 and half. So we have 1 half, 2 half, and it moves on. These ones are very, important, especially when you are calculating for the area, but then the numbers there is beyond a certain number. We will solve example for you to see exactly what I am talking about. I think the examples are not here, but we will solve examples on this. Then we will see how do you call it, the whole thing is. Especially, let me say this. You see, here we are divided into what? Into 10 equal what parts. So in the other one, if for instance the number that you have been given is not an even number, or the divisions are not even but they are odd, then it means that some of them you have to apply this particular rule to solve it. So here with the Simpson's multiplier, you will not get it as the same as what, as the ones with what, the even number where you have 1, 4, 2. But then depending on the question and depending on what exactly you have to use and solve it. I don't have that particular question here, but I will get the question so that we will solve that particular question as to how you can also solve question based on what, using this what, intermediate what, coordinate. Or if you have also seen any question, you can also solve using what, intermediate what, ordinate what, to solve it. So what I'm saying is just sit down and understand the whole principle here, then you can what, you can solve it. Though here we can go into cross sectional what, area. From here we said that we can calculate water plane area at every draft, so we have calculated for that. Now we are going for cross sectional area at every what, section. So at every section, here is cross what, sectional what, area. So how do you call it? When you cut the vessel into maybe transversely, when you cut it, these are the cross section what you will get. So this is calculated at every section to give by equation CSA, which is equal to 2h all over 3 into bracket 1 y naught plus 4 y naught and all that. So here we have the y naught down. This one is not water plane now. It's not water plane, but now it's what, cross sectional what, area. So for instance, in your building that you are staying in now, when you cut it, you will see some vertical what, section. So this is the vertical section, and we have the baseline being the water line. We have the 1, and we have what, we have the 2. So this one we have from the mid section to the other end becoming y2, the other section to the other place becoming y1, and the other section y0 to that place becoming what, y0. And we have it height too, so the height also is there. So calculating for the cross sectional area, we have the water plane area 0, 1, 2. We have the area which is y0, y1 and y2. And we have to calculate for the Simpson's multiplier, which is 1 over 1, 4 and 1. We have the area product. So we have y naught times 1, y1 times 4, and y naught times 2. Then you calculate all its what, area what, product. So when you calculate all its area product, you can come and put it here, and then multiply it by what, 2. So when you multiply it by 2, you'll be able to calculate the what, the whole total what, cross what, sectional what, area. So you get the whole what, total what, cross what, sectional area. That becomes a cross sectional area. So let's solve example. The midship section of a ship with design draft D equal to 8 meters is given us. So we have water line and we have half coordinate. So calculate the mid sectional area. So this has been given to you. So the water line is there. You bring your half coordinate, then you multiply by our Simpson's what, multiplier. And the same thing implies to that. So you have multiply the 1 times the half coordinate, you get the area product at that particular section. 4 times 9.35, you get that. 2.9.50, you get that. 4.9.50, you get that. And 1 times 9.50, you get that. So this becomes what, your area what, product being 110 times what, 90. So then the same thing, the intervals are what, 1, 2, 3, what, 4, and you can see it from here, 1, 2, 3, and what, and 4. So you have the 1, 2, 3, and 4. So you divide it by 4, and the h there becomes what, the equal to 8 meters is given by this. So the volume is draft. So you have your 8 there over 4, 2. making it 2. So if you're having the 2 there, then CSA is equal to 2 times H over 3, making 110.9. Yes.
Sir, listen. Why is not it divided by 5?
I'm coming. Okay. Where is mine? Where is the question? I'm coming. I'm coming on. I want to check where the question is. You said why is it not? Hello. You said why?
Why is it not 5?
8 divided by 5.
Why? But the division. Have you checked the division? From 0 to 1 is 1 division. Is that not it? Is that not it? Hello. Hello.
Yes,
Yeah,
sir.
from 0 to 1 is 1 division. Is that not it?
Yes, sir.
From 1 to 2 is 1 division. Is that not it?
Yes, sir.
From 2 to 3 is 1 division. Is that not it?
Yes,
And
sir.
from 3 to 4 is 1 division. So when you go here, you see the H from 0 to 1. This is 1 division. Is that not it? And from
Okay, sir.
1 to 2 is another division. So if we were to use this will become what 2 or division.
2. Okay.
Okay. So you should be able to.
Thank you, sir.
Yes, get that. What time are you supposed to close the class?
5 o'clock.
5 o'clock.
5 o'clock, sir.
All right. So,
Yes, sir.
basically, this is how you can be able to solve for how do you call it mid-section area, and for calculating for cross-sectional area and water plane area. So you'll be able to calculate for water plane area and cross-sectional area. We will end here. Yeah, we will end here. Then, God willing, next week we will go by calculating first moment of area about midship. Then we will be able to we will finish the whole thing. So God willing, next week we will be able to deal with second moment of area about the center line. We will be able to deal with that. Then we continue. But at least where we've gotten to up to today, try and solve them. Okay.
Thank you, sir.
All right. Any question?
Thank you, sir.
Okay.
I've got a question. I've got a question. With respect to the intermediate part of it, that's under the area of water plane. You said something about odd numbers and even numbers. So I would expect to use odd numbers for intermediate, and for normal one, just the one that intermediate for even numbers.
Okay, I'm coming. Sometimes the question will specify. It's not like the question will specify, but then the question will demand you to use intermediate. Okay, so what I'll do is next week I'll find intermediate question, then we'll solve it for you to know where you can use the intermediate and where you cannot use the intermediate. Okay.
Okay.
Yes. I will find that so that we solve, so that you'll be able to know where you can use the intermediate and where you cannot use the intermediate. All right. Please, any question?
So one more thing. This h over 3, that 3, please, how did you actually come about it?
All right. It's from the formula itself. We said that
it has been a predominant formula itself.
Yes,
that's how it has been generated.
Yes, so that's why I said go and see how you'll be able. The Simpson's first rule, there is a proof. You see, this is where the proof starts from. You understand? So after you have been able to prove,
Okay.
Yes, after you be able to prove, this is where the whole thing would start from. So it's from the proof, the three. It's from the proof. That's why I said you should go and learn what they prove, as in how you can be able to prove that. So it's from the proof. Okay.
Okay.
All right. Any question?
Sir, please, there's set. As if you get there is a first one and a second one before you add them. I don't get the second one. How do you get the second set?
I said that set is for this particular one. Is that not it? This is what we are talking about.
Yes.
And we have the set. Is that not it? Hello.
Yes.
Yes.
Sir.
What I am saying is, you see, this is for us to explain to you, but you shouldn't be writing this particular set when you are working. Okay, don't write set 1 4 1. Then you come down, you write 1 4 1. Then you come, then you write 1 4 1. Then you come, then you write 1. No, don't do that. Just write Simpson's multiplier. The SM is Simpson's multiplier. And what I said earlier on is that with the Simpson's multiplier, the first rule of Simpson's multiplier, we are saying that from the formula, it should be y naught plus y 1 plus y hot 2, and the 1 times y1, 4 times y1, and y 2 times 1. So that is what? That is the formula. So when you go here, this is the formula. The h equal to h over 3 into bracket 1 plus 4 plus what? Y what? 1. This is the formula. All right. So when the question is given to you, okay, this were the coordinate that was being given to you. These are half coordinate that was given to you. Okay. Now you have been able to get your stations. You see, you say, so from the aft, you will get to 1, you get to 2, you get to 3, you get to 4, you get to 5, you get to 6, and all that. You have gotten that. Now your half coordinate at the aft, you have been able to get 1.0. At the 1, you have been able to get 2.8, and all that. You have filled that. Now what you're saying, if you multiply your Simpson's multiplier times the half coordinate, you should be able to know the area. And we are saying that since the vessel is actually in regular body and ready to calculate for its area, it's prudent you multiply the half coordinate by what? By the Simpson's multiplier. Then you can get what? The area what? Product. So then, this is what the formula says. 1 4 1. All right. So when you go to 2, it's more or less like when you go to 2, you are starting from 1 again. Okay, when you go to 2, you are starting from 1 again. It's more or less like you are having 2 buildings, two hall attached to each other, right? So when you are counting 1 2 1 4 1, okay, when you are the cadet, when you are still cadet, when you are doing counting twos, you see 1 2 1 2, you understand that. Use that as an example. When you calculate 1 2 1 2 1 2, is that not it? You don't count 1 2 3 4 5. I said 1, then another person say 2, then another person will say 1. So that is the whole concept here. So when you count, one person say 1, the other person say 4, the other person say 1, the other person say 4. Then they will ask you, okay, all the ones group somewhere, all the twos group somewhere. You understand? So that is the principle we are trying to set here. So 1 4 1, you have to start the other one, because the formula says that it has to also start from 1. So when you are starting, it means it has to start from the 2. The other one has to start from the 2. So you have to start 1 plus the 1 will give you 2. So it means that the 1 is already there, the other one is already there. So the 1 plus 1 will give you 2. That is how come you write a 2 here. But if you write 2 straight away, you will not be able to understand why the 2 is there. That is why we've actually break it down here for you to know the 1 plus 1 will be what? Will be 2 here. Do you understand that?
Yes, sir.
Are you sure?
Yes, sir.
Okay. All right. Any question? Any question? Hello.
No.
All
Yes,
right.
sir.
Okay. I think some of your data is getting finished. You are
Yes.
from 70 to 57. To me, that the data is finishing. So, God willing, next week we will continue. Okay.
Adios.
Okay.
Yes, sir. Yes, sir.
All right.
Yes, sir. Yes, sir.
So, God willing,
Yes,
go
sir.
get questions and solve them. Okay.